Hello, my name is Sonja and I'm a first-year PhD student studying the role of pre-existing fractures for basaltic dikes propagating through hyaloclastite. Hyaloclastite is a small-scale heterogeneous but large-scale homogeneous material. It can form when magma interacts with water or ice and is found in many places across Iceland. My field area is an extinct and partially eroded caldera called Björfjöll in northeast Iceland. The caldera was filled with hyaloclastite and intersected by regional dikes after the volcano itself became extinct. We collected drone-based photogrammetry data from 3 sites within the caldera and compared orientations of fractures and dikes in virtual 3D models. Most fractures and dikes follow one of 3, possibly 4 orientations. The most prominent one, marked here in red on the right, aligns with the strike of the divergent plate boundary during the time of emplacement. I want to show 2 examples of more complex behavior. The first example is a dike which has at least 2 sharp changes in direction. At least partially, it seems to have used a pre-existing fracture, but despite the fracture continuing, the dike changes its direction. Comparison to stereo nets shows that the first and third exposed segments belong to the tectonic set. This might indicate that in some instances, following pre-existing fractures which are not aligned with the strike direction is energy efficient, but when a suitable fracture of the initial direction comes up, the dike once again changes its direction. The second example I want to show here is a dike which splits into many small branches and offshoots at the top and the bottom of the exposed section. The branches at the top align with the fracture sets observed all over the caldera. This example shows that not all fractures are suitable for dikes to propagate into and how a dike searches for alternative propagation paths in intact rock. We hope these examples help to understand when dikes in the shallow crust follow pre-existing fractures and when it's preferable to fracture previously intact rock. This could provide useful insights for monitoring of active volcanoes, such as on the Reykjanes Peninsula in southwest Iceland, where hyaloclastite is a common material. Thanks for listening.